My name is Ayşegül, and I'm really excited to share what's new with cognitive services with you. First, I want to acknowledge how hard this past year has been for all of us, but especially for essential workers and healthcare professionals. We are very thankful for all of their work. As an asthma patient who has spent a lot of time in emergency care, I am deeply aware of the limited technology they work with day to day. While telling about the new and improved cognitive services features, I would like to explore what we can build to enable healthcare professionals every day. Let's take a look at what's in our agenda today. First, we will talk about the app we want to build. We will talk about how we can automate the administrative processes, how we can enable human connection and knowledge transfer, how we can incentivize and monitor safety of public places. Finally, we have tons of resources for you to learn more. Let's start with why. While innovations in medical treatment continue to improve over time, many healthcare providers are still burdened by archaic processes. Manual inputs into legacy systems and lingering paper-based processes create a huge amount of busy work for healthcare providers and distract from higher value activities. 2 years ago, I have become a frequent visitor of the emergency rooms in San Francisco. Silicon Valley being the technology hub that it is, I was surprised to see how very little of the breakthroughs made it into the medical system. Not being able to breathe and feeling like there is a monster sitting on my chest, it required an enormous effort to sit in yet another lobby and fill in an endless amount of forms. Once the filling of the forms is over, someone whose time could be used doing more urgent things would type in my information while asking me the questions again. It is really hard to talk when you can't breathe and hard for healthcare professionals to juggle data entry and make informed decisions in the time that they have with a patient. Because I wasn't able to tell all my history, I ended up going back to the emergency care until I finally got the right treatment. The information transfer is not only a patient's problem either. Most emergency care professionals work long hours, sometimes up to 24 hours per shift, because it takes a long time to transfer patients between the shifts. What are some of the problems that we can solve here for both the patient and the healthcare professionals? Let's start with admission. What if we can have a smart virtual assistant that can help us check our symptoms to make sure if we need to be seen by a doctor or maybe can get an online appointment? Information gathered by the virtual assistants and many patients can help healthcare professionals to triage and prioritize urgent care needs. By using text-to-speech and speech-to-text, we can make the health bots more friendly and accessible. We can easily automate the admission process by taking a picture of our ID and possibly past visit notes from our doctors and test results. Okay, now we collected a lot of information through a virtual agent, but how can we make it easily consumable? Having a lot of data means more information is shared. Doctors and nurses are dividing their attention between multiple patients at a time. Can we analyze the data and abstract and emphasize the important information? Yes, we can. Maybe use the data to give more personalized care as well. Finally, it is important to keep the healthcare facilities safe. Knowing when an area might be contaminated is important to keep everyone safe. There are more features than we can build. Possibilities are endless. Before I get ahead of myself, let's focus on the minimum viable product and let's talk about our health bot. Let's start with our virtual and friendly health bot that checks our symptoms. A virtual health assistant and chatbot for symptoms checking and prioritizing using Azure HealthBot service. Azure HealthBot's platform that was built especially for the healthcare industry with their requirements and needs in mind. It allows us to develop and deploy compliant virtual health assistants and chatbots that are powered by AI, that we can help the medical professionals to improve their processes and their services, even reduce their costs. HealthBot comes with out-of-the-box intelligence trained language models with clinical terminology that understands medical intent also extracts different aspects of users' utterances such as conditions, symptoms, gender information, and location. Natural language processing specific to clinical terminology and medical intent that enables natural flow of conversation outside of the expected flow. Users might ask a question that is not specified in your scenarios, but still be able to get their questions answered from up-to-date, credible sources. Symptom check-in protocols are sophisticated expert systems that were created by mapping thousands of symptoms and conditions and added risk factors. HealthBot can also determine when to break its flow and hand the patient off to a doctor or a nurse. When you're getting started with HealthBot, you can choose from a selection of scenario templates. When you import a template into your HealthBot instance, it will automatically create the assets required for your scenarios, such as language models and data connections. Templates are a great starting point for building out your HealthBot, and you can easily customize and extend any part of your scenario after you import it. You can incorporate your patient's data and add medication updates to your flow, for example. So let's dive in how we can create and customize one. To get started, the first thing we need to do is to create a HealthBot resource on Azure portal. Once we create our resource, you can find the management portal link at the overview page of your resource. On HealthBot management portal, you can browse through different scenario templates and take a peek at their flow snapshots by clicking on them. Let's import the vaccine eligibility template. Once imported, we can go in and see the flow chart in the editor and further customize the template using drag and drop widgets for adding a new scenario, logic, or an action. You can save and run your workflow to test easily on the same editor page too. You can use the template as it is or customize, but there might always be some questions from the users you haven't anticipated. For example, while I go through the eligibility questions, I also wanted to ask if the vaccine contains anything that I might be allergic to. My questions can be answered from a trusted source, although the questions was not part of the original flow. So very cool and very smart. Sometimes smart is not enough. You might need to hear a friendly voice, especially when you're sick and worried. You want your virtual HealthBot to be friendly and more accessible. We have text-to-speech and speech-to-text integration built into the HealthBot, but you might want to customize the voice to make it sound more natural, or even use a voice talent to create your business's reassuring voice. Lastly, we have a multi-language, multi-speaker universal base model that enables Microsoft and our customers to build a highly natural text-to-speech voice model with 10 times less data, adapted to new speakers and new styles of characteristics. Let's hear the difference, shall we?
I live at 9th Avenue and 20th Street, 3 blocks away from where I work. I live at 9th Avenue and 20th Street, 3 blocks away from where I work. I live at 9th Avenue and 20th Street, 3 blocks away from where I work.
It is a fascinating technology, but also makes you think, if you can train your boss's voice and make a call to HR about a promotion. Not quite. To be able to train a custom neural voice, the voice talent has to confirm by stating they are aware that their voice is going to be trained to be used in text-to-speech. Unless you have the voice actor's permission recorded, you cannot even start training your models. What an elegant solution. Custom neural voice has recently been generally available, but companies like BBC, Progressive Insurance, and Duolingo have been training their own custom model to create their brand voices. Training a custom model is not the only option. You can choose from 129 new neural voices today, over 54 locations. You can further customize the pre-trained neural voices for your own purposes. You can change the intonations or pitch to make it sound more exciting, for example. You can even teach the voices how to pronounce names like mine by giving the phonetic sounds. Okay, back to our healthcare solution. Once the patients that needs to be admitted are identified, we can automate their check-in processes by asking them to take a picture of their IDs instead of filling out forms. With optical character recognizer, we can even get the critical information from their doctor's handwritten notes or test results by uploading the pictures to our systems. Let's look at some of the new features of form recognizer that enables us to create these solutions. One of the new features is the enhanced table extraction. In this example, although lines are not drawn, we are able to recognize and extract columns and rows. We can detect the check marks and their values as selected or unselected as well. Pre-built invoice models are in preview. I don't have to worry about if I paid a bill or not. I can take a picture and store the data easily, and I love this feature. Form Recognizer's preview allows page selections for multiple pages from PDFs and TIFF files. You can provide specific page numbers or page ranges as an input parameter to extract the data only from those pages. A new addition is also ID layout, which you can use for passports and other kinds of IDs like driver's license. Finally, the languages supported are extended coverage of 64 additional languages, bringing the total to 73 languages. You can try out all of these features and custom tray your own layouts using open source Form Recognizer sample tool starting March 15. First thing we will do is to add our API key and endpoint to the tool. After that, we can use the pre-built model to get ID data by uploading an ID and by choosing the model type ID. Instantly, all of the information is abstracted as a key value pairs with a high confidence level. Data is available to download as a JSON or comma-separated values as well. You can get the same data using the REST API endpoints in your application. This is truly a great feature set. A lot of data is instantly in a structured format for you to use in your applications. Okay, we've gathered a lot of information through HealthBots, and we've abstracted information from IDs, nodes, and invoices. Now the question is how to make all of this data easily consumable by the healthcare professional and patients. Healthcare is generating over 4 trillion gigabytes of data per year. We have customers that generate more than 1 million documents and clinical notes a day by their medical professionals. And that's very typical. We see millions of raw text documents that are produced a day. Thousands of papers are published in medical publications also. Thousands of clinical trials are introduced every year. It's a lot of medical and clinical data that is in a raw text. We were looking to create a service that will be able to decipher and understand the clinical language and make sense of the text. Our new service, Text Analytics for Health, is a natural language processing service for the analysis of clinical and medical text that is trained on diverse data types so that it can be understand different types of clinical text. Text Analytics for Health is capable of doing multiple natural language processing tasks, like performing named entity recognition, entity linking, relation abstraction, and understanding negation. The goal here is to power the understanding of clinical documents for multiple use cases. With named entity recognition, a Text Analytics for Health is able to identify aids in medical terms in text. It doesn't have to be even a single word. It could be several words that are combined to express a medical term to determine the boundaries of the term. For example, the non-Hodgkin's lymphoma is a 3-word that describes a medical term. It will be classified as a diagnosis. We have asthma classified as diagnosis and Benadryl classified as a medication. An IV is a route and 20 milligrams is a dosage that we're able to identify. This is what we mean when we say we identify and classify terms into domain-specific entities and attributes. In entity linking, we associate those medical entities with the standard ontology concepts from the clinical coding systems. There are more than 24 clinical coding systems used globally. They're all different standards of medical coding systems used in this industry. We can associate the codes with those entities. For example, diffuse large B-cell lymphoma is classified as diagnosis and tagged with the UMLS code. Each identity would have associated many coding systems. Diagnosis would have ICD, medications have RX norms. This is done in a generic way to capture all of the different coding systems. In relation extraction, we are trying to understand the semantic relationship between the entities in the text. So there are a few different types of relations. Attribute to entity, for example, a dosage to medication, and entity to entity, abbreviation detection, such as DBCL, means diffuse large B-cell lymphoma. Last but not least, in negation, which means the text analytics for health can detect a negative qualifier. In this example, the clinician noted that she did not have associated shortness of breath, chest pain, itching, or nausea. She has not noticed rashes. These negations are important to note and accurately document as they aid in the clinical differential diagnosis and in recording of accurate care and treatment plans. This information is also important to note in the billing and reimbursement processes, as many treatment algorithms may detect a stepwise treatment process to obtain certain medications and procedures. There are two ways to access text analytics for health: through containers and hosted APIs. And telemetry data is captured, and it's a number of characters each request of text. The hosted web API is provided as an asynchronous operation only to allow for processing of larger documents without a negative impact of the latency. Hosted API output persists for 24 hours and then deleted, and at no point we do see your data. One of the examples of applications that uses health analytics along with Search API is for being able to abstract information from medical publications. Being able to abstract that information for clinical trials and studies is very important at a time the innovation needs to happen really fast. I can't wait to see other applications built using health analytics. Text analytics for health is available today, but requires you to apply to have access to it. You can apply at aka.ms/csgate. Finally, the two important new service features are helping companies to go back to their offices and help keep the essential workers and customers safe. First one is the Face API's update for a faster, more accurate face detection model with face mask detection functionality. The second one is spatial analysis, also able to detect face coverings, count people, and measure social distancing, as well as define dwell time in specific areas. Let's take a look at how the APIs work. First thing Spatial Analysis Service does automatically is to configure your camera for more accurate data, which is great and allows you to run the service in a container in your own network on an IoT device for low latency and security. What are some of the use cases for the first feature, people counting? I've heard many ways different countries was able to implement people counting in common places like supermarkets. Where I live in San Francisco, there is an actual person in front of most stores that has a clicker that counts people going in and coming out. It is not the cheapest or most reliable solution for most common places. A museum or a hospital with many doors and many rooms would be much harder to control and limit the number of people. With spatial analytics, all you need to do is to subscribe to the people count event of the API and get a property back with a person count. You can also get the region information for each person, which is used for drawing the rectangles in this video. One thing to note is the service's ability to track a person after they're behind an object and reappear in the view. This is not done by face identification or identification of the people, and every person is represented with an anonymous ID. The second use case is something that is top of the mind these days, that is social distancing. With spatial analysis, you can set a minimum required distance between people, and you can warn of failure to maintain distance as well. By saving these AI insights, you can create a historic report and determine trends in pandemic compliance. This is the same video footage for the store, but in this case, instead of people counting, we are running the social distancing operation. Person distance event. Notice that with a single camera, you may run multiple operations simultaneously. For the purpose of these demos, we run people counting and social distancing on the same video feed. We can use the entry and exit functionality to monitor entryways for traffic and maintain optimal occupancy. We can detect when people enter or leave a zone or cross a line. We can calculate the times people spend in an area for dwell time and loitering, as well as detecting their interest. In this video, you can see how you can determine wait time at a checkout queue. We drew a polygon around the checkout stand, and as people enter to the polygon, we start the timer and stop the timer when the person exits the polygon. By looking at the timestamps of the event, we determine the time spent by a person at the checkout line. This final video is from our coworkers entering and exiting the building. Again, the people count event has the property of mask and confidence value. It allows us to encourage the mask use and safe practices. Majority of the people are avoiding hospitals for preventive care these days, which is not good for our common health and a strain for the preventive care services. Maybe if we have a historical data of safe practices in an office, most of us might feel more comfortable being in a doctor's office. Again, none of these events defined by spatial analysis services are used to identify people and uses anonymous IDs to represent each person. Wow, that was a lot of services and features. Let's recap how we can use these new and improved features to help healthcare providers and essential workers. We can ease the pain of the patient services by using HealthBot's predefined templates and knowledge base. HealthBot is also easily integratable with the tools like Teams and Power Apps to allow ease of use and development. HealthBot is also easily integratable with your data on Azure and services like speech and new neural voices. With the extended features of Form Recognizer, it is easier than ever to scan documents like IDs, invoices, and create custom layouts, which could drastically reduce the paper waste and data entry burden over time. And what a relief is that? Health analytics is revolutionizing health data by making it easily digestible for clinical trials, patient care, and medical research. It is easier than ever to extract important health-related information and relationships from a wide variety of data types. We have spatial analysis and face APIs to help us keep public places safer. Spatial analysis also gives us a lot of more historical information over time about the use of public spaces and a way to identify cues, interest areas, and more. I hope you're inspired and excited to try out these new features of cognitive services to make life better and enable everyone. Please check out all of our resources and code samples at aka.ms/Cognitive Services.